All right, let's dive in and unlock some absolutely essential tools for your GCSE Maths toolkit. We're talking simple and compound interest and the even bigger ideas of growth and decay. Now, getting your head around these isn't just about passing your exam, it's about understanding how money really works, how your savings grow, why a new car loses value, and even how things like populations change over time. So let's get started.
Okay, so picture this. You put £100 in a bank for 2 years. Simple enough, right? How much do you have at the end? Well, the answer isn't quite as straightforward as you might think. It all comes down to one single crucial word that completely changes how we do the maths. And that word, well, it leads us straight to our very first tool in the toolkit, simple interest. This is the most basic, most straightforward place to begin. So what is simple interest? The key thing to remember is that the calculation is always based on the initial amount you put in, the principal. That's it. This means the actual amount of interest you earn each year is fixed. It's the same amount again and again. It never, ever changes. To really see how this plays out, let's follow an example. Meet Nigel. He puts £250 into an account, and it pays 4% simple interest per year. Let's track what happens to his money over 6 years. So, how do we work this out? Step 1, and this is the most important part, is to figure out what 4% of his starting 250 quid actually is. We just multiply by 0.04, and that gives us £10. Now, because it's simple interest, he earns that same tenner every single year. So, for 6 years, that's just £10 times 6, £60. Add that on to his original 250, and he ends up with £310. Easy. So, after 6 years, Nigel's earned a total of £60 in interest. Why? Because that same predictable £10 was added to his account year in, year out. Remember, that fixed amount, it's the absolute key to understanding simple interest. Okay, so that's simple interest ticked off. Now, let's upgrade to something way more powerful. Compound interest. You know, if simple interest is like walking up a steady slope, compound interest is like a snowball rolling down a hill. It just gets bigger and faster all on its own. And here is the absolute game changer. With compound interest, we don't just look at the starting amount. No, we calculate the interest on the current total in the account. This means you start earning interest on the interest you've already made. It's a powerful feedback loop that makes your money grow much, much faster. Let's put them side by side just to make this crystal clear. Simple interest, a fixed cash amount every time. Compound interest, a percentage of a balance that's always growing. What does that mean in practice? It means the actual amount of cash you earn each year gets bigger and bigger and bigger. Let's watch that snowball effect for real. We start with £100 at 10%. After year 1, simple enough, you've got 110. But look at year 2. You now calculate 10% of that new total, 110, which adds £11. The interest payment itself grew. And by year 3, you're calculating 10% of 121. You can see how the amount being added is speeding up. Now, doing that year-by-year calculation is slow, right? And in an exam, you need to be quick. So we use a shortcut, the multiplier. For a 4% increase, our multiplier is 1.04. And to do that for 7 years, you don't multiply by 7. No, you raise the multiplier to the power of 7. So what does this mean for Jasmina's investment of £1,200? Well, we take her £1,200, multiply it by 1.04 to the power of 7, and you can see that after those 7 years, her investment is worth nearly £1,580. That is the power of compounding right there. So we've seen how values can grow and accelerate. But here's the really cool thing. You've actually already learned all the maths you need for when values shrink. This brings us to our next tool, which is basically just the reverse of what we've been doing, depreciation. We've all heard of this, I'm sure. You buy a brand new phone or a new car, and pretty much the second you start using it, it begins to lose value. Well, that loss of value, when it's calculated as a percentage each year, is exactly what we call depreciation. And here is the absolute key takeaway, the thing you have to remember. Depreciation works in exactly the same way as compound interest, just with a percentage decrease instead of an increase. The maths, the formula, the process, it's identical. The only difference is the value is going down, not up. Let's use a classic example to see it in action. A brand new car costs £20,000. It's estimated to lose 15% of its value every single year. So the big question is, what's it actually worth after just 3 years? Okay, These steps should look really familiar. First up, we need the multiplier. Now, if something loses 15% of its value, that means 85% of its value is left over. So our multiplier is 0.85. Since this happens for 3 years, we raise it to the power of 3. Then, just like before, we multiply that by the starting price of the car. And the result? After just 3 years, that 20,000-pound car is now worth just over 12,282 pounds. That is a massive drop in value, and we calculated it using the exact same method as compound interest. So we've looked at interest for growth and depreciation for, well, decay. Now it's time to zoom out, because both of these ideas are just two sides of the same coin. They're part of a much bigger picture, and there's a single master key that unlocks it all: growth and decay. You see, this type of calculation isn't just for bank accounts and cars. It's a fundamental pattern that we see everywhere in the world around us. It describes how populations grow, how bacteria multiply in a petri dish, how a virus can spread, how a hot cup of tea cools down, and even how radioactive materials decay over time. And every single one of those scenarios can be described by this one single powerful formula: B equals A times k to the power of n. You take your starting amount, A, you apply your change, that's the multiplier k, for a certain number of times, n, and that gives you your new amount, B. And the real secret sauce, the most important part of this whole thing, is k, the multiplier. And here's the simple rule that governs everything. It all comes down to the value of k. If your multiplier is bigger than 1, you've got growth. That was our 1.04 for the 4% interest. If k is between 0 and 1, you've got decay. That was our 0.85 for the 15% depreciation. It really is that simple. So let's test that master key on a totally new problem. A population of 25,000 people is increasing by 4% a year. What's the population in 13 years? Well, it's just the starting amount, 25,000, times our growth multiplier, 1.04, to the power of 13. See? It's the exact same formula, just in a completely different context.
We started this whole thing with a simple bank account, and we've ended up with a universal formula for growth and decay that applies to almost anything. You now have the master key. So my final question to you is this: now that you know what to look for, what else in the world around you follows this exact same pattern of exponential change?